Hey, what's going on, folks? It's Mike here, and welcome back to my Programming Language First Impression series, the series in which we take a look at a programming language for the first time for about an hour and just try it out. This is the honest first impression of what it's like to work in a language, what its community is like, its syntax, and again, just getting an overall feel for the language. Now, with that said, today's episode, we're going to be taking a look at the Wren programming language, which this is one that just kind of popped up enough times on Hacker News where I'm like, I gotta take a look at it. Because we've looked at some scripting languages like Lua and Ruby and these types of things, and specifically languages like Lua, which tend to be languages that are meant for embedding. I thought Wren would be an interesting thing to look at. And I've truly never looked at Wren other than just seeing the name pop up a bunch of times on Hacker News, as I mentioned. And if we scroll down here to like the third search, here is, Wren, a small, fast, class-based concurrent scripting language. And this sounds like a bunch of awesome things. You get the dynamicism of scripting. It sounds like this is something I can embed. It's small and simple, and I get some concurrency, which sounds like an awesome thing to check out here. So with that said, let's go ahead and take a look at the webpage here. I'm going to open up the GitHub just in case, there's some information there. There might be some other interesting things on maybe Hacker News or whatever that we'll branch into, but it looks like there's, a bunch of articles on this language, and I think we should just give it a little bit of attention and take a peek here. So a classy little scripting language here. Okay. So what is it? Wren is a small, fast, again, class-based concurrent scripting language. I like that. So think small talk. Okay, so class-based, so object-oriented. That's what I always think about when I think about small talk. And Lua-sized, which means, we can embed this and, again, use it as a scripting language, let's say in a game engine, which is where, again, I picked up or have seen Wren pop up a number of times being part of game engines. Let's see, and with a dash of Erlang. Okay, so I wonder if that's going to be for the concurrency model, let's say. I wonder if it's using actors or if it's, I see in this example, I see fibers, so I'm assuming fibers and coroutines and some sort of cooperative processing that way. But yeah, anyways, this looks like a nice little language that looks, a little bit like, well, honestly, a mix of languages that we've seen or looked at. This is almost looking C# or Java-ish, and again, we've got the class here, var, so sort of dynamic. I wonder if this is dynamically typed here. Let's take a look here and see if we can infer, but we could see we've got fibers here and some nice syntax here on this array here of things that we're doing some task. So this is going to be kind of interesting here to see what this language looks like. So again, let's just keep exploring and we'll try it out here. So Wren is small. The virtual machine, the VM implementation is under 4,000 semicolons. So I like that versus line count, counting the semicolons. Probably easier to grep for. Maybe that is the metric we should use. How many statements do we have? But anyways, that sounds like it's pretty small here. Again, we could go directly to the source code. So this is cool. This is pretty open source, I suppose here. And if I look at the repo, we opened it up here. This is still being updated. Let's see, 3 months ago. Looks like there was some updates here. So yeah, I'm assuming it's building. There's been some releases in the past few years, some tidying up here. So maybe this is just production ready and ready to go. So anyways, Wren is fast, a fast single pass compiler. So that's cool. Single pass. To type bytecode and compact object representation to help compete with other dynamic languages. Okay, so what do they mean by this? Wren performance. Okay, so I guess there is a, as part of their reference here, let's just go ahead and take a look at that. Even though most benchmarks aren't worth the pixels they're printed on, people seem to like them, so here's a few. This is giving us a good, I guess, feel for the language, right? It was written at least with the intent of performance. Maybe folks again can look at these look like micro benchmarks here, and maybe somebody has a fancy way in Python 3 to really optimize things or whatever, but this is looking good. Obviously it can do some quick things here. LuaJIT, yeah. So there's lots of variations. We covered Lua on this series many episodes ago, but Lua's really cool. I like these small sort of embedded scripting languages. I think they're really cool and have their very important use in software engineering. But there's LuaJIT. There's like a fast Lua. There's a bunch of these variations of Lua worth taking a look at too. So So yeah, it looks like it's right up there on the speed, so shorter bars are better here. Yeah, just to be clear, less time, less milliseconds or seconds spent here. Okay, so and why is it fast? Okay, so language comes. I mean, it said it was compiling. It's a virtual machine, so it's getting a compact bytecode. So that's kind of the neat thing here. I will also mention with the Wren programming language. I mean, it's worth mentioning here, just through a quick Google search, that my understanding is the author is or originally was Bob Nystrom, who's written these fantastic books here. I think if you're watching my game programming content here, I've probably mentioned, at least at some point, the Game Programming Patterns book here, which is an awesome book. It's freely available online, which I'd encourage folks to check out if you want to learn some design patterns. But again, this is a book, again, not an advertisement of any sort. Well, I guess it is an advertisement since I'm showing it, but to the extent that I actually purchased a hard copy of this book because I enjoyed it so much. So, so he's written this book very nicely, and the other book, let's go ahead and bring that up here, that you might be more interested in, this Crafting Interpreters text here. So again, Bob Nystrom, somebody who has a lot of experience. I think he's been working on the Dart team or was previously doing that. I don't know exactly the time frame there, but so he knows his programming language stuff and has written this really, really fantastic book, which I think also is available for free on the web, but I have my hard copy as well. Okay, and it's always worth pausing the video to prove it. I mean, here it is in my hands in reverse so that you can see I'm mirrored, but a good sized book, and again, it's worth thumbing through at the least if you're interested in programming languages. And then if you're actually going to do this, or for me, if I was going to design a course, which I'm considering at some point, this would be a book I would read, or like at a university course or something would be awesome, I think, because it is building kind of what we're looking at here. Maybe there's some inspiration for this Wren programming language here. So I believe the language that he writes there is called LOX otherwise, because they've worked through a few chapters and built a little subset of it. But anyways, so that's a little bit just about the author and the experience. So again, I'm not surprised that this is somebody and the team that maybe is currently working on this. Just looking at the commits here from Ruby OX1. I don't know if, but it looks like, for folks that are working on it, that, it's not surprising to see that this is fast, or that is the sort of emphasis here. So we'll see how fast we'll run it here. So anyways, Wren is class-based. There's a lot of scripting languages out there, but many have unusual or non-existent object models. Wren places class front and center. Okay, so yeah, why not? Well, I guess that'd be kind of interesting to think about. We'll read a little bit here. I mean, this is already kind of interesting to see on the documentation. I mean, this is a pretty scripting languages are generally pretty small, so I can kind of see it here. But it's nice to see. Maybe I'll be kind of curious if this documentation goes into the whys of the design. Maybe that'll be apparent as we look at it. But anyways, Wren is concurrent. Lightweight fibers are core to the execution model and let you organize your program in a flock of communicating coroutines. Cool. So coroutines are something that I've been thinking a lot about, and fibers, again, which have this idea, again, in programming languages, if you're not familiar with fiber, sometimes there are other names for these, like lighter weight threads or these types of things. I want to be careful with the word, but basically when I have fiber or coroutine, usually what that means is, and this is worth drawing out, what I can do is have my program, and let's just say our program is executing. Maybe we're in our main function. Maybe we have a loop here. So draw a little, box diagram. Then maybe I call some function like, I don't know, let's just say it's like a graph traversal, or, I don't know, you're doing some like pathfinding algorithm through a graph or a map or something. And let's say this is a fiber here. So basically what can happen is I can go off and do whatever is in this, pathfinding algorithm here, pathfinding. And then usually what you'll have is some sort of instruction here. So, you'll do your code, and then you'll have some sort of like yield or something, which basically means pause this function and jump back to and continue execution where you were. Okay. Now, if this fiber itself that I've identified here is in a separate thread, then you're sort of getting two things happening at once. But fibers still allow you to basically have a separate execution going on here, but then you can sort of yield as you need to, and then you could, later call that function again and call resume, and we'll restore the state of that particular fiber here. Okay. So that's kind of the idea here. And what's neat about that is if you have some computation, like, again, I'm thinking about things from a game perspective, where you have to do so many iterations in 60 frames per second or 30 frames per second. So that's your budget, so to speak, 16 milliseconds, or let's say about 33 milliseconds. You can sort of just do a part of the computation in a fiber. Okay. And then you can resume it later when you have more budget or more time in your loop to complete that algorithm. Okay. So you can kind of break things up if you need to, which is really, really a neat thing about fibers. And of course, if you have fibers executing within threads, you can get concurrency and have this sort of, boost in performance by doing things concurrently. Okay, so that's just a little introduction. Maybe we'll actually try out some fibers and see the examples to motivate it further, but that's a cool thing. That's a cool thing to see here. And again, I'm doing things in C++. We'll get to our coroutines eventually in that series, and then in D, same thing. We'll get to fibers and see some of their advantages there. So anyways, Wren is a scripting language. Wren is intended for embedding in applications. Yep, it has no dependencies. That's awesome. Small standard library and easy to use C API. Awesome. So it compiles cleanly as C99. And C basically is, as they say, the lingua franca for programming languages. So that's cool. It's in a very compatible C99. So yeah, it's easy to embed. I mean, let's try it out here. So we can try it out in a browser here. Which is awesome. I love when we can just try it out here. I'm going to keep that as a fallback in case for whatever reason I can't set up the command line interface. Let's see what the getting started looks like. And then if you want to get involved here, there's a nice little guide here. In Wren, just noticing the logo as a bird, or a type of bird here. So let's see. Wren's ecosystem is small but full of life. Okay, cool. There's a Discord community, a mailing list. So it might be cool for folks to check this out and contribute. It looks like it's still being actively contributed to and getting bug fixes and these types of things. It's meant to be a small language, but it'd be kind of interesting just to see or hear from you folks in the community what you are building, if you have used it, as we do this exploration. So always nice to see that there's a community here, an issue tracker, things to hack on. Awesome. So, plenty of stuff to dig into if you are excited about this programming language after watching this video or trying it out yourself. So anyways, let's go ahead and get started here. Let's start from the top here, and then if we get stuck, we'll dive into our browser if we need to. So let's do it on the CLI. Let's see if we can download an executable and kind of get started with that. So the command line interface is a tool. Okay, so we can run our Wren code. Maybe we'll even try to embed it if there is a example. That would be kind of cool here. It's designed to be minimal, built-in language features, standard library, and the VM itself. Okay, cool. Okay, so basically, I'm assuming we just need to download like the GitHub repo or something. You need to make a tool using language VM. That's what CLI. Okay, it's not bundled as part of the Wren project, and since its own project as a standalone tool, you can run. Okay. Okay, so I guess we can run this. I guess, again, it's sort of like Lua. We can, run the command line interface tool, I'm assuming, standalone and try out some scripts, or there's probably a version of this that we can embed. That's what I'm guessing here. Okay, so maybe we go to downloads here. So let's see. Is this the About page? Yes, so I'm going to go to downloads. Let's see here. Yep, and on the GitHub Wren CLI. Let's see here. Linux, Mac, and Windows. Awesome. So I won't have to think too hard. Let's go ahead and get a download going. All right, that was easy. I just extracted it here. Let's take a look at the README. See what we got here. Small CLI project. Okay, it's backed with libuv for I/O functionality and is a work in progress. Okay, it's a work in progress, so we'll keep that in mind as we're going through it. But cool, just one executable like they're mentioning. No real dependencies here. So let's see if I can just run it. Okay, it's already executable. Wren, cool. Nice little logo there. let's do, something like this. Okay, so it's just allowing to execute. How do I quit here? Quit, exit, Control C. Let's see the help here. Help, okay, show the command line usage, file. Okay, we can pass in the file and then any arguments here. And again, just for our records, the version, you can see here, 0.40. Okay, so we'll keep that in mind for getting things up and running here. Let's just keep that tucked away for now. Behind me. Let's close this. And let's start looking at the language here. Okay, so from the getting started. Okay, cool. Embedded in our code. Let's start with the CLI just to get a feel for the language, and then maybe before we leave, let's try to actually embed it and see what's in the embedding guide and just go through those instructions here. I think that'll be fun here. Okay, so once you have somewhere to explore, it's time to learn the language. Okay, so let's just go in order here, and then again, we'll look at maybe embedding the language here. Okay, so the syntax. Let's move that to the side here. I think we're ready to do some typing. Wren's syntax is designed to be familiar to people coming from C-like languages. Okay, that's many of the languages that we've looked at, and then the ones I'm mostly working in these days, C++ and D. Okay, we need a Wren extension here. So the good news is I'm just gonna kind of build things in this directory here, and let's just do hello Wren here. Yeah, let's see what goes on here. So comment. Okay, so we're not going to get any syntax highlighting. I don't have any Vim plugin for this. But let's see what we got here. Okay, so it's got a bunch of reserved words, the identifiers, naming rules. Okay, identifiers start with a letter or underscore. Okay, pretty cases sensitive, but it doesn't really matter. No conventions. We've seen a couple languages where, the first letter has to be capitalized or things like that, and that has meaning. That's always kind of an interesting choice. But I probably think these days, it's nice to use your own style. Let's see. Okay, new lines. Okay, let's just see if we can do system.print. I want to see if I have to have a main or not. And I need maybe I need a semicolon. Let's just try. Wren CLI. The file is going to be hello Wren. Hi. Okay, so I don't need a semicolon. If I put one in, is that an error? Nope, don't need it. Okay. Very nice. We've come a long way. We have programming languages smart enough to not need the semicolons. Although that can always help the parsing, I suppose, here. All right, let's see here. Okay, so I could do some funky things with the syntax. So that's just a nice job here. Let's see. So it is really just taking all the tokens and, as we're parsing the language, just looking for the nice valid token, and the white space doesn't really matter. Okay, cool. Wren uses curly braces to define blocks. Okay, so stuff we're familiar with. If we've got our sort of Boolean operations, the and operator there. We can put stuff in different scopes. Okay, very neat. And then let's see here. After it's come to have a method or function that just evaluates, returns a single expression. Languages use this to define these. Wren uses. Oh, okay, interesting. So single expression. Okay, however, it's pretty common to have a method or a function that just evaluates. So this is like the most abbreviated form here of something. Single expression. Okay, I could put it within curly braces here. So I guess this has meaning, or can I use, I saw that word var here. Can I do something like that? Expected, okay, maybe I have to do a little bit more work, or maybe there is it Pascal? Okay, we're jumping way ahead here. All right, we'll figure that out here. Now, if there's no new line at or after the parameter list in a function, the block may contain only a single expression. It's automatically returned the result. Okay, I guess it's just a result here. It's exactly the same as doing this. Oh, I see. Okay, just return this. I thought this was some sort of, maybe this is, we'll find out, some like very introducing like a lambda syntax or something here. Okay, oh, the statements are not allowed on this form since they don't produce value. Okay. Well, I explored a little too early. Okay, which means nothing. Starting with class for if import return var or while. Okay, if you want a block that contains a single statement, put a new line in there. Okay. Okay, so we're getting a feel for this here. Okay, let's see, numbers.map. Okay, so I'm excited to start taking a look at some of this stuff here. Syntax. Numbers. Okay, so I'm going to have a map here for n, multiply whatever the numbers array is, and then filter, which I guess is what where is, all the numbers less than 100 here. And I guess this is kind of like an infinite sort of sequence, right? It's just going to produce all these values and then return based off this filter. So that's kind of cool here. Let's see. Okay. Oh, I see. Okay, so I see why they're motivating this expression here, because in D we have the uniform function call syntax where we do use the dots for chaining, right? That's what they're saying here. But for this, we're just saying, okay, I can write these single sort of blocks. Let me make sure I'm using the right thing. Single expressions here. So for this map here, that I guess is just taking in this function dot where. Okay, I mean that's pretty clean. That's a lot less typing. That's interesting. That's kind of cool. That's something we've never seen. I mean, so already this is kind of a win. And this is why we like to explore lots of different programming languages, from compiled to scripts and all these different things, to find some neat insights, let's say here. So, okay, precedence and associativity. Let's see what else we got here. Okay, so these look like our standard operators for the most part. Inclusive and exclusive range. That's kind of interesting. Let's see, make sure we're not missing anything. Shifting operators is for a test here. Again, we're starting to see this. D has something like this. Not seeing this. I wonder if C++ or other languages are going to do these sorts of things here. But this is really useful. Again, if you have or are checking to see if one type is, another type of thing, or I guess there's a few different ways that you can use is, but that's the idea here. And then we've got our conditionals here, and assignment is with equals here. Okay. Okay, let's keep going here. Let's see, that's the syntax of values, booleans. So I'm going to go through some of this quickly just because I want to get to some of these other features and then see if we can get to the embedding in an hour, which would be really cool. The common escaping things. String interpolation. Okay, let's try out a few of these things just as we're going along here. Let's complicate our string a little bit here. Let's do a string interpolation thing. There we are. I could just put %. Okay, let's evaluate something. 5 plus 5. Hello, or hi 10. Okay, that's going to be our hello world example so far. Raw strings, triple quotes, cool stuff. Yeah, very cool. You can contain quotes. I actually like the triple string syntax. I've seen a few other. I mean, you kind of have to have a few variations of this, but that seems to fix the problem of having quotes, because I've seen other languages that'll use like backticks or something for raw strings, and then you have to escape the backtick symbol if you use it or something. But this kind of seems to fix every problem, I guess. Unless, and I don't know what this trick is if you want to put triple strings in one of these things, but maybe just you can't escape them or something. Let's see here. Okay, one more example. Embedding Wren code inside a string safely. Okay, markdown string with embedded Wren code example. Now, why is that safe here? I guess it's still just a raw string. All right. Anyways, let's look at some other stuff. Values or range. Okay, cool. Love languages that have ranges in them. ... and triple dot. That's actually a kind of nice inclusive and exclusive. I wonder how often programmers make that mistake where they actually like double tap or triple tap in this case. But that's kind of a nice syntax thing here for ranges. And maybe a good way to remember that is more dots means more inclusive, like 4 through 6. So we should probably, try this out here. Let's see. So this creates the range from 3 to 8, including. Oh wait, maybe that's range is a little object. Dedicate a little. So maybe I got that backwards. Maybe this is okay. This creates a range from 3 to 8, including 8 itself. Okay, I might have reversed that, but that's okay. Just having the different ones. So let's see. What would the thing be to remember here? 4 until 6, like ... I guess in the language, or even in like text, if you see like ... that's kind of like a waiting or until. I'm just trying to give myself a way to remember that so I don't mix it up. But 4 to 5, so not including 6. Okay. So that's an easier way to remember it. I'm sure there were great debates. Range are commonly used for iterating over sequences. Great. Yeah, let's see what we got here. We got lists, slices. Once you use a language that has slices in it, it's hard to not, right? So a slice is going to be a view into this list. And then we get the different syntax here, which is a reason I like these 2 dots or 3 dots. So that's kind of a nice, very nice thing here. So let's make a list here, and we'll copy and make the alphabet. Or no, let's just do numbers because I accidentally hit 1, 2, 3. No, let's put in some strings here. A, B, C, E, F, G. I don't know, something like that. Let's take a slice. And let's do this for the list from 0 to 4 here. So we should go all the way to ABC. And let's just see if we can just print that out here. Print out the slice. Yep, simple as that. So the 0, 1, 2, 3, and 4th index. Okay, so we get the whole thing here. Let's see, what's this here? Oh, what's going on with this negative stuff here? Is that letting me print it backwards? Let's try that out. Slice 2. I guess if both of these are negative here, negative 1 here. System print slice 2. Let's see what we get here. Oh, interesting. Yeah, getting the negative indices. I'm trying to think. I'm sure we've seen that in some other languages. I'm just starting to forget at some point. But yeah, that's kind of a neat little feature there. So, all right. Easier than, I mean, a lot of other languages will just, you'll have to call some other function like, dot reverse or something on this. And, maybe there is something for that. Null, Wren has a special null, okay, which is the only instance of this class, null, okay. And it functions a bit like void. Okay, so we have the null type. That's always good. We can't go back to in our C languages where we have 0 or something. All right, we're moving right along here. I mean, we might actually just finish the whole language because that's the cool thing about, this is a, small little language here. So let's do a few things with lists. Let's see here. I mean, we know kind of some of the stuff about accessing them. The thing I'm looking out for is to see if I can mix types here, like in Python, or if they are all the same, because oftentimes I imagine that's where we're getting a lot of the speed up, if I can have, any sort of type here or not. Let's see. We're calling this a list. Okay, list is a compound object that holds a collection of elements identified by integer index. Okay, that answers my question there. So this is very Pythonic in the way that I think about lists. And then I can have 1, 2, a, and then let's put in true. And then let's do the system.print lists here. Make sure I save. And that works here. Beautiful. Okay, that's a very nice... okay, so this really is a really nice, pretty flexible scripting language here. Because really, once you have this data structure, it is one data structure to rule them all in a sense. Okay, so we can access stuff, we can print stuff. Again, negative indices count backwards from the end. I actually kind of like that in the sense that, I should think about this a little bit more here from an error handling perspective. I guess if I still go out of bounds, we'll see if there's some error checking here, if that would throw like an exception or just seg fault or whatever the appropriate thing might be to do here. But it is kind of an interesting case. I wonder if these are bound checked. I wonder what the sort of safety story is here. All right, so let's keep going. All right, we know about slicing. We've played around with that. The negative bounds still work here. If we want to add elements, how do we do that? We just do add here. Okay, lists. I wonder if we can do... Well, I'm just going to try to break things here. Let's just add maple here. So let's like initialize the list and run it. Okay, that's interesting. I wonder if that generated a new list here. Let's see. If I go here, then do lists. Does that... Okay, so that'll just add it here. So that's kind of an interesting thing to try here. Because this probably returns the new list or something. Anyways, cool. Easy enough. Again, if you're coming from Python or something, that's going to be very, very similar here. You can insert in the specific positions. Awesome. And of course, I'm sure, when you dive into these things, you got to be aware of the performance. And if you're allocating or, if this insertion is just pushing on the back versus having to reallocate the whole list or something, those are probably interesting things to dive into further. All right, we could add lists together just with the plus operator. Simple enough here. Let's add some of our lists together. Let's see if I can do it within the print and if that what that does here. Let's add it to our slice. Let's see what happens here. Okay, so that is working here. And can I do like a new list plus slice 2, and let's do the system print new list here just to get an idea of the semantics, see what's going on here. Yep, looks like it's adding that together, and that is concatenation. I guess I don't know about the semantics yet, but we can find out if we modify one of these elements to see if it modifies it in all of them. I'm assuming so, that this is returning or creating a new list here. But that would be, again, another thing to try out here. Okay, removing elements, simple enough here. Awesome, all right. So let's go ahead and keep moving on here to maps. One of our favorite data structures here. Maps, okay, or associative arrays, dictionaries, have many different names here, hash tables, depending on the implementation. Oh, yeah, and they're listing them here, well ahead of me. Nice job with the documentation. Again, for either the community members or if Mr. Nystrom wrote this himself, always has done a nice job writing. So this is kind of fun to take a look at here. And I will mention here, before I end the video, I will take a note at the game engine that I saw on Hacker News that is using this language. This is the initial thing that brought us here. I just want to mention that. Okay, so simple enough here to create a map here, comma separated. I mean, this looks like a lot of other languages that we use here. So yeah, it's pretty similar to Python, so I'm not going to spend too much time on it here. And then let's see here. So we can check here, and then we're going to return the null value. It's kind of nice to do this null value return when it comes to language design. Well, okay, let's do capitals here. All right, let's see here. Up Georgia. This is gonna. What is Georgia? Augusta. Let's see here. Sorry, this is going by U.S. states here. Let's actually put in something there. That's gonna be bad. I might have messed that up. Sorry, Georgia folks here. Columbus. Here, do something that I know here. Doing them backwards though. Ohio. All right. All right. First and foremost, let's just print this out here to see if we get a nice little view of our dictionary. We do, which is great. And then we should just print out, you know, something like. In our capitals, let's go ahead and try out, see if we have California, and see if it just prints out null ahead of time, which it does here. And this is kind of nice. Some folks like the true false for these types of, well, I guess, I mean, this case is actually demonstrating that we really do need null here, but you know, if we were going to do this check and say like is California or something, for California, there we go. Let's do capitals, California. I mean, we're basically caching this result here, if I can type it out properly here. There we go. So then I can use it if I do find it. So again, that's another reason I was just thinking about this recently for, you know, why are these associative arrays going to return like a null value or something? You kind of want the pointer to the data so that you can just search for it once. Oh, and let's see what I've done here. Snuck in another semicolon, which are illegal. But now I'm getting that same null result here. But if I had found it here, then I can use basically this and say if, you know, is California, then do system.print, found it. And in the fast path, right, I don't have to do a lookup again or something. I've already got the pointer to is California, and it's going to give me back Sacramento or whatever. Okay, and then here I can do the false case. Did not find California, Cali capital. How about let's just do that. Okay, for my Californians watching, welcome. Hopefully I got that right. But all right, it's got this nice built-in support, and you know, what a really nice thing is, you know, if I'm building a new programming language or a scripting language or anything to have these built-in types, I think we've kind of learned that and maybe seen that to have just this simple syntax. A lot of folks have kind of conformed to this. So it is kind of interesting. I'd be curious if folks have suggestions as to something, you know, better. I mean, I guess we can go full on Lisp mode or something and just have, you know, the data as the code. But, you know, getting any you know, it's hard for me to think of a syntax, at least of the languages that I've looked at, for something more or fewer characters or something to type that isn't also very clear. So very nice here. Okay, so we can iterate through some things. So for loops, let's go ahead and do this. Let's keep working with our capitals here. So for, I don't know, C in capitals. And let's just write them out. System.print. And let's write out our capitals here. Okay, so we got them here. Now we've got the, I guess we've got the full data structure here. Yep, we got to use bird.key, or in this case, c.key. Now can I just do .keys or something like that? And will that update the type? Let's see. Okay, that works too. Okay, so keys, there's probably one for values. Next example. Okay, so read my mind, that's always good. Start here. Again, I'm just taking things I know from other languages and trying them. It's just kind of nice here. Okay, method calls. Okay, so Wren is deeply object-oriented. Okay, so that means most of the code is in a class here. Okay, so let's see what's going on here. Method calls. Wren is deeply object-oriented, so most calls. And it said it was Erlang inspired, so maybe we're going to get into that here because it's, I don't know, it's mentioning this thing about receiver, so let's see if that sort of message passing, these small talk Erlang features are coming to life here. So Wren is deeply object-oriented, so most code consists of invoking methods on objects, usually something like this. Okay, so that's what we've been doing. I guess we've got the system. I guess this would be considered like, I mean, is this just like a static class or something, and we're just calling these, you know, functions or these wrappers, something like that. So anyways, you have a receiver expression here, system, followed by then a name and the argument list, of course. Okay, so we've got this here for our list type. Let's see what's going on here. It says the VM executes a method like so. Evaluate the receiver. Okay, so that's just meaning like the class and the arguments from left to right. Look at the method of the receiving class, invoke it, passing on the arguments. Okay, sounds simple enough. But let's see, there's something different here, okay, which is why we do this series, to learn some different things. Unlike most other dynamic type languages, in Wren, a class can have multiple methods with the same name. Oh, okay, interesting. Multiple methods with the same name. Okay, so we've seen that before with other programming languages with overloading, right? But let's see here. As long as they have different signatures, okay? Interesting. So I wonder if a lot of dynamic type languages, I mean, again, I haven't written much JavaScript, but is this true? Maybe some folks can let me know and timestamp wherever we're at here. In JavaScript or something, do we not have overloading because we can like change things very dynamically? Is that what we mean here? Because otherwise this sounds like overloading to me. But maybe let's learn here. Signature includes a method's name along with the number of arguments it takes. Okay, in technical terms, it means you can overload by arity. Okay, arity being the number of arguments you have. Okay. Okay, so I mean that sounds like method overloading, but I'm curious that if other dynamic languages don't have that. Okay, interesting. For example, the random class has two methods for getting a random integer. One taking a min and max, and the other just a value here from 0 as a default. Okay, perfect. The folks who made this language are exploring further. Language like Python and JavaScript, these would both call a single int method, which has some kind of special optional parameter. I see. So they would just have the start default to 0 or something as an argument. I see. So that's how they do the overloading here. Okay, so this type of varied code isn't ideal, so Wren doesn't encourage it. Okay, interesting. In Wren, these are calls to two entirely separate methods, int with 2 parameters and int with 1. This makes it easier to define overloads. Okay, so yeah, this is basically just talking about overloads, I think, since you don't need the optional parameter. Interesting. Okay, so again, my Python, which I do a little bit more of, and I don't do much JavaScript these days, mostly in P5.js is where I've done most of my JavaScript. It looks like you have to have the default parameter. Interesting. Okay, interesting. So maybe we'll have to do a series on, whatever the latest ECMAScript is. Update myself on that. Okay, and it's also faster to execute. I see, since we know exactly. I guess, this is the advantage you have with a VM if you're sort of ahead of time knowing exactly what you're calling or not what version or what optional arguments or something. I see. Okay, makes sense. Okay, getters. Okay, so we got our properties here. Okay, so things like count and so on. Okay, so getters have no parentheses. Okay, so that's sort of like a, I think these are more like C# and Java things where they've really leaned into properties. I've seen these a little bit in D, but I haven't used them too much, to be honest, because you can use with or without the parentheses. So count here is a computed property of an object. Okay, getters. Interesting. Okay, kind of nice. I'm actually kind of a fan of dropping the parentheses too and not having them if you have 0 parameters. I don't know, it's less to type. And they tend to chain a little bit better. I kind of like that when you're actually typing. So folks can let me know what you think about that, but we'll see your thoughts. Okay, so if you don't, so, you know, general guidelines. Okay, so it's giving some style guidelines. So it modifies an object or has a hide effect, put the parentheses. So that's kind of a nice way to think about it. Or if it supports multiple arities, right, to be clear. Otherwise, it could probably just be a getter. Okay, kind of nice here. Okay, so I'm going to kind of keep zooming through this so we get through some of the other things here. Subscripts. All right, let's get into our control flow. Control flow, I think we're going to be familiar with. Boolean values, logical operators. Again, just doing a quick look here. While statements, variables, for statements. Let's see if there's anything interesting in. I mean, we could do this type of thing here, which is nice. I like this. I don't like to have to define another data structure, right? I just want to define it in line there and have it ready and available. So that's kind of nice. Just have the list there. Break statements, continue. Just kind of poking around here. Numeric ranges, again, nice with with 2 or 3 dots, as you remember. And let's see, iterators. Okay, lists and ranges cover the 2 most common type of loops, but you should be able to define your own sequences. Okay, so there is an iterator protocol. I mean, this is quite nice for a scripting language. I mean, you know, in many ways, it sounds like there's enough here. It sounds like a really powerful scripting language. I mean, this is the type of thing that you want to do if you're using this, embedding into some other language and creating your own data structure, since it's sort of class-based, right? Your own, you know, iterator or range protocol, as is mentioned here. Again, iterator probably coming from the C++ side, but ranges, again, be able to write something like this and just say, hey, this is a numeric range, but write it for your own type. Okay, so it basically just compiles down to this .iterate function here, okay? And then you can write that, and then it'll figure out how to pop off the first value for you in that sequence. Okay, so cool. It's all there. Variables. Okay, so quickly we're getting into classes, functions, concurrency, and then, yeah, we'll try to do some embedding here. We got our scopes, we got our variables here. Now, the one thing I just want to see here is if this is a dynamic type, and then I'll keep moving us along here. Assignment. You can assign it. So let's see here. Walks up the stack. When using. So let's just try to see what happens here, and let's see what kind of error messages we get here. Let's create a variable a and assign it to 1, and then let's assign a to string here. Okay, let's see if it breaks. Is that strongly typed? Not so much here. Okay, so this is a true scripting language, and that kind of makes sense here. For one reason, it's like var, like I think of in like JavaScript or something, but that we can kind of rebind this and have the type. And the reason, again, why I think it makes sense is because, right, if we look at our data structure, it is just a bunch of vars here. Let's see, where did we make some when we concatenated, right? 1, 2, a string, and a Boolean value here. So they have types, but we can kind of rebind the type there, which is, yeah, that's pretty neat. So I'd definitely say this is a fun language here. And here we are in functions. Okay, so let's see. Like many languages, functions in Red are little bundles of code you can store in a variable or pass an argument to. Okay, so notice there's a difference between a function and a method. Exactly my next question here. Very well written documentation. Every question I've had is answered in the next sentence. So nice job to the team that puts this together. Since Wren is object-oriented, most of your code will live in methods on the classes, but free-floating functions are still eminently handy. Yeah, I like this because, you know, if I write like a math function or something, or a little algorithm and call it like sort or something, I don't know if I necessarily want to put it in a class or have a bunch of like state that I'm managing, or risk somebody else adding state where it doesn't really belong. So just being able to add a new function is kind of neat. So that's cool. So fn.new. Okay, so at least you have some way to organize these. Okay, so that's kind of cool here. I wonder if this makes it really easy to do things like higher order functions where I guess you just have this type here. So anyways, let's see. Every question I ask gets answered shortly here. And we use call on it. Okay, interesting. So create a new function, takes the blocks execute, and then you can explicitly just call it. Okay, that's interesting, versus just putting the parentheses here. Oh, but this is bound to this variable here. I see. Versus just doing say hello. That probably makes sense, since we could do here. Let's write out this example. This makes sense. Let's explain why it makes sense. I mean, let's do it here with. I mean, you could with this variable a here. Let's set it equal to new system.print hello, and then I could do a call. Okay. Oops. Let's see. There we go. Yeah, and that just kind of works here. Oh, this is fun. This is a fun language. Let's see here. Okay, let's get into some other cool stuff. Okay, functions aren't very useful if you can't pass value to them. The function above takes no arguments. To change that, you can provide a parameter list surrounded by the pipe or the bar here. Okay, to pass arguments to the function. Okay, because we don't really have types, I don't need to specify like string or anything. So I just put the bar here. And again, what a compact language. So again, this is a new kind of use of a syntax here that if we've seen it before, again, it's just my memory over a few years of these videos I've forgotten. So that's actually kind of a pretty neat syntax, and that makes a little bit more sense of what we were looking at before. Actually, I think we have seen this in some other languages. I mean, this is almost like, for those of you who have taken like a discrete math course or something, when you're writing the sort of like existence proofs or whatever, you kind of write them like this, right? You write the curly braces and you say for all, x, and you put in a bar, and there exists, and etc. So I wonder if that's part of the inspiration of this syntax. I mean, thinking about it, this is kind of what you see in the proofs. It's kind of nice to see it in the syntax too. So anyways, yeah, that's kind of cool here. I like that. I wonder if it made the parsing easier. I mean, that was one of the things that they mentioned, a one-pass thing. And if you're embedding this scripting language into another language here, you kind of want those to be one passes things, right? You don't want to do multiple passes and all these other sorts of things. So anyways, that's kind of cool here. Okay, so the body of a function is a block. Let's see here. Null by default, otherwise you can explicitly return here. Okay, cool. So this one's going to return null. This one will return a value here. All right, closures. Yes. Okay, as you can expect, functions are closures. They can contain variables defined outside of their scope. They will hold on to closed over values even after leaving the scope where the function is defined. Okay, so let's see here. So class, this guy here. Here the create method returns the function created. Okay, so this is returning it here. On the second line, that function references a variable I. That was defined above it here, outside of the function. Even after the function is returned from create, it's still able to read and assign to I. Okay, so every time that I call this function, I'm returning, a new function I'm defining, I guess, and adding to it, okay? So another programming language is in C++, if you're following that series. These are more like functors, which are closures, meaning that they can have some state with them, right? That persists, okay? Callable classes. Okay, because fn for function is a class and responds to call, any class can respond to call. It could be used in place of a function call. Okay, so this is like our, I mean, this guy just is callable. Let's see, any class can respond to call. Now, interestingly, we don't have a return type or anything on these methods. I was just noticing that here. That we have to explicitly specify, because why would we have to? So that was just another little syntax thing. Very, very concise and well put together language. But anyways, this is particularly handy when the function is passed to a method to be called like a callback or event here. Okay, so cool. Okay, so let's kind of keep going here. Block arguments. Okay, complete example of fictional class. Okay, so we're doing stuff with callbacks here, defining some functions here. Making a clickable thing, and then firing some event here. Okay, so clearly the type of thing that you'd want in a very dynamic scripting language, right? Okay, cool. Let's get into just a little bit more classes. Oh, we did functions, but yeah, let's see here. But then we're getting in the meat here, the concurrency and so on. Every value in Wren is an object, and every object is an instance of a class. Even true and false. Okay, so truly, fully, or object-oriented. Going full, like, I think Java had everything as a bool, or integer was a class, you know, in the early days. Or again, we might have to take a look at Smalltalk, since it's one of the inspirations here. Okay, so anyways, here's how to define a class. We can add methods to it. With arguments. Okay, these are looking more like the arguments that we're used to, where and when. Let's go ahead and just pop this guy in here. Oops. Here, let's do it here. And let's paste in our unicorn class. Let's see, and if I want to make an instance of this, can I define the type here? Let's see if I can do this. Well, let's see here. How do I create an instance? Okay, so here's how to make the type. Here's how to do this. Okay, we got a bunch of things that we can do with it. All right. Yeah, let's see. Getter, setters. How do I make an instance of this? And then we can move on. Okay, but we are seeing interesting stuff like index. So hold on. So here, let's see here. Is it just unicorn new like we were seeing here? Var unicorn test. Let's see here. Unicorn meta class does not implement new. Okay, so we know that here. Let's see. Do I just make it a like this? And then can I just do unicorn test dot prance where I don't know. I'm just gonna put A and B here just to see if this works here. Unicorn meta class does not implement prance. Now I've got it here, but let's see what I did wrong here. Probably just calling this wrong here. So let's see here. Let's skip around a little bit and see if we can get to an example here. There is an implicit this. Okay, so a couple other things that's handy to know. All right, let's see if we got a full example. Construct. Okay, we do have a constructor, and new, I guess, is what we define here. To create instances of class, we need a constructor. Okay, so we do have to define one. Whoops. So unicorn meta class does not implement this. Okay, so maybe we never actually successfully are able to create a unicorn here. So construct new. I'm just going to leave this empty here. Let's see here. Because I'm probably going to have to call, I'm guessing something like this, dot new. It's not a property, so I think I was supposed to put in the parentheses. Okay, so there we go. Okay, simple as that here. So now we can actually instantiate these guys here, unicorn.new. I like that. Okay, simple enough here. Now I wonder if construct. Let's again just do a little bit of playing around here. Construct and allocate. Let's see if it, you know, do I just have to call any sort of constructor thing? Because why that's kind of interesting. It looks like that's the case here. Just because I can name it anything. So I can, I'm sure new is a convention here, but I could do allocate or whatever here. Just because I'm trying to think of maybe we would want to grab this memory from somewhere, or maybe we can call into some other library. That's probably not the purpose so much of the scripting language, but just kind of think of that. That's kind of interesting that the constructors, well, I mean, they're very easy to grep for. Here, I guess I'll just sort of leave it at that. But I can name them anything I want, which is kind of a new thing here. And maybe that meaning, how I'm allocating that could mean something. Because in games, you know, we often have many different types of allocators. I mean, we're thinking about heap, stack, but, you know, stack-based allocators, different types of pools of memory that we're allocating from that might be heap-based or stack-based. So that's kind of interesting stuff to think about. So all right, there's a bunch of stuff here we skipped here that looked interesting, like indexing. We are getting close to our hour mark though, so I don't want to run too far over, but it looks like I can put operators. Let's just look for index here. Unicorns are not lists. Okay. But we can basically overload those index operations here, which is cool. This is just telling that you can't, you can't do it for this particular class. So maybe there are some examples in the GitHub repo to do that, but that's kind of cool here that those are defined here for operator. What would the right be? Operator overloading, I guess, is the right thing, but for the index thing here. Maybe you can do that for plus and minus, I don't know. But let's just kind of keep zooming through here because I want to get to some of the other cool features of the language here. Fields, okay, we can have this sorts of stuff here. All states stored in instance is stored in fields. Each field has a name that starts with an underscore. Okay, so that is a naming convention here to have underscores. Okay, fair enough. It's kind of nice, I guess, to have a uniform thing. Some people like to choose. Many people have adopted this convention, though, over time. So not something totally out of the ballpark here. Let's see. Okay, so we do need setters and these types of things to provide access to these fields. And we have some examples here. Meta classes and other things here. Okay, so there are static things coming, static fields. Interesting. Inheritance. Okay, so again, we're getting quite into this, and maybe super. Okay. Okay, and they're working on the documentation here. That's fine. Cool. I mean, this is a pretty, well, like they said, object-oriented scripting language, which is, not a bad thing to have, and oftentimes fits in games nicely. So, anyways, let's get to the next section here. Concurrency. Lightweight concurrency is a key feature, and they're using fibers. Okay. They control how the code is executed and take place in exceptions and error handling. Cool, and that's really like our last sections. We'll briefly look at errors, but I want to look at this and maybe embedding too. So this is helpful for people. I drew the little diagram if you stuck around from the very beginning on what I thought fibers are or how to explain them briefly, but fibers are a bit like threads, except they are cooperatively scheduled. Okay, that means Wren doesn't pause one fiber and switch to another until you tell it, right? You usually call yield or stop or something like that. You don't have to worry about context switches at random times and all the headaches those cause. Wren takes care of that. Okay, so they don't use the OS thread resources. And again, fibers can also be very useful for just asynchronous I/O, right? So again, basic idea, when you'd want to yield a fiber is when you are opening a file or something. Then you can yield, go back to your main loop, and then resume execution and check if that resource is available, whatever thing you're loading. So for input-output, fibers are very, very useful. And they're less heavyweight than, launching an operating system thread in that instance, right? A function calls could be a lot cheaper. So that would be the right use case for it with like asynchronous type of I/O, which is exactly the type of stuff that you want to do in a scripting language. So very, very, very cool. Okay, so anyways, each just needs a bit of memory for its stack. So they're not like stackless coroutines or something, but they have a stack. Fiber will get garbage collected. Right, okay. And everything here is, the scripting language garbage collected, which is really, really nice. You don't have to worry about that stuff, which is, again, the point if you're embedding a scripting language is to get productivity for, writing games or scripts or plugins for whatever system that you're using. Okay, so they are lightweight enough that, for example, you can have a separate fiber for each entity in the game. Yeah, because it's basically just like a function call. Wren can handle thousands of them without breaking a sweat. Awesome. So let's create a fiber. Let's do it. Let's just copy this example. Fiber equals fiber.new, and let's just call system.print. New separate fiber is here. And let's do a little like for loop here. Let's see if I remember for I in 3 dots. So let's go up to 10. Let's say system.print I. Okay, and I'm assuming I have to invoke this. Yep, we have to do fiber call, so let's just do it here. Let's just call it at the end. Okay, so it works. We're able to get our new separate fiber. Let's do something with, let's put this in a loop here. And let's see, what should we do here? So for I in 1, let's do something like from 40 to 50. 40 to 50 there, 3 dots. And what we'll do here is let's see here. Let's have a call every time in this loop, and then let's every time, how about for the first call, we'll stop until we should be called again. Let's see what the syntax for that. Let's see, so how do I suspend? Okay, once you've created a fiber, you can call out with the call method. This suspends the current fiber and executes the call once until it reaches the end of its body, or until it passes control to yet another fiber. If it reaches the end of its body, it's considered done. Okay, so let's think about this. So print, okay, is done. Oh, we have this is done here. I see. So let's see here. I mean, this is going to call its body. This will reach the end of its body once, so we'll have to think about this just for a moment here. It automatically passes control back to the fiber I called it. It's a runtime error to try to call a fiber that is already done. Okay, yeah, makes sense enough here. Here we go. Here's our thing that we need, yield. Main difference between fibers and functions is that fiber can be suspended in the middle of its operation. Okay, so yield it is. So I could just call fiber. Let's print once here, and then just do yield. Okay, so basically we have this fiber here that when we call it, it'll say new separate fiber. I'll call this once, and then it'll yield. Okay, and then what we'll do here and say if fiber dot is done, not is done, then we'll call it once. Okay, it'll execute once in its internal loop, and then we'll call system print back in, for all intents and purposes, our main little thread here. Okay, so you can see we get this interleaving of this execution. Okay, fiber is super fun to play around with, but that's the basic idea. Okay, so hopefully that makes sense. And again, like first try, nothing complicated. If you're coming from like a C# background and have used their coroutines or something, that should be familiar. And D has fibers. Other languages that have this stuff is going to be pretty similar here. Okay, and of course we can pass in some data and so on. But let's see here. Full coroutines. What we've seen so far is very similar to what you can do with languages like Python and C# that have generators. Okay. Those let you define a function call that you can suspend and resume. When using the function, it appears like a sequence you can iterate over. Wren's fibers can do that, but they can do a lot more. Like Lua, they are full coroutines. They can suspend from anywhere in the call stack. The function you use to create a fiber can call a method that calls another method, that calls some other method, and so on and so on and so forth. Okay. So I guess it's more accurate to just call them coroutines, okay, because they have this ability to preserve their stack, and I guess there are different, again, flavors of coroutines that are stackless or not, or maybe some that allocate elsewhere. All right. Okay, so fibers have one more trick up their sleeve. When you execute a fiber using call, the fiber tracks which fiber it will return to when it yields, right? So if I had this fiber, technically I guess I could call into another fiber, do another fiber call for some other allocated object, and then I can kind of unwind. So that's nice. Yeah, we have this system. And that's usually what you want. Okay, but if you're doing something low level, like writing your own scheduler, okay, because I could have a pool of fibers, maybe priorities associated with each of these fibers, you have transfer. Okay, that's cool. Switches execution to the transferred fiber and forgets the fiber that was transferred from. Okay, previous one is suspended. Okay, but it keeps its state. So that's cool. Yeah, transfer. So it's like an unstructured go-to. Very cool. So yeah, if you're writing your own little scheduler, that's nice here. Okay, brief look at error handling, and then I think we'll take a peek at embedding because we're over the hour limit, but let's see here. Error messages, I mean, we've seen a couple of them when I've just made silly errors, but let's see. So compile time stuff, it'll tell us at the point of where we make the error. It's running in the virtual machine, but I just want to see, are there like exceptions? Okay, there are try catch, which looks like that is available here. And then you could call abort here. Interesting here. Supposed to error message. Okay. Failures. Okay. All right. So we pretty much got through all the language, which might be the first time we've done that on this series. I can't remember. Here, quick. I got to click on this link. Modularity. All right. So I can have modules. Okay. I'll just leave that. But anyways, I think we pretty much made it through all of the guide here, which is really, really nice. I mean, it's a really nice scripting language. It's got pretty much all the features that you would want here. It is nicely documented. the different modules that we have here, classes. I didn't click on all the link. I think I have clicked on all the links now, other than this embedding one. So anyways, let's take a look at it here. So Wren is dynamically typed, but C is not here. And there is garbage collection. Okay, so these are always things you have to think about when you're embedding a language, being careful with how you mix resources, meaning if I allocate something in the scripting language and I use it from C, don't free it in C. Let the scripting language free things. Usually, that's kind of the case here. Okay, so this seems like it's going to be, since it's a stack-based language, I'm assuming, or the virtual machine is, it's going to be similar to Lua's API. Okay, let's see if we can, I guess we could probably just run an example, or at least look at it here. Okay, so you include the header, you set up whatever the configuration is. I guess we'd have to think a little bit more what that is. And then we can write a, well, this is in C, I guess, and then just pass it here, icy, with whatever the configuration is going to be, and have the function here available here. Okay, so I think that's, maybe this is the extent that we'll look at it. And then it's got within the interpreter, this is on the C side here, you can just execute strings that'll execute. So, if you've used PyBind, I have my PyBind series if you want to check that out. I mean, this looks like all the same stuff here. And then you clean it up. So this is a pretty clean example here. Let's just compile it to see if it works, though. Include. I might have to get rid of that include there, but let's see. We will give this 1 minute to try here, because I'll need, what will I need here? If I download this, is this the right thing here? Let's just see here. Wren CLI. Okay. Let's download this. I've got the source. The include. Okay. Okay. Let's try it here. This will be good test. So let's get rid of this. Let's clone the repo. All right. Nice small project. Cloning fast. And then let's go into the repo. I can type properly. I've got the source there. I'm gonna do this right in line. This is the worst thing to do. But I'm just write a test.c program here. And then let's set paste. Just paste in that example here. Oops. Let's see, Wren. Where are we? Embedding. There we are. Let's copy this. I think that's a typo, but let's see if this just works here. See how good my skills are here in getting code to compile. Let's maximize this a little bit here. All right, we got all our little examples there. So overall, not too much to get started. Oh, cool! This example has a little error handling too on the C side, with this little error function. Okay, so let's go ahead and let's assume it's perfect, and that's the bulk of our code here. We are treating this as a C file, it looks like. What do they call this? Test.c. Okay, what do they call this? Now it's saved. Oh, gotta move into my directory. Again, I did this in the worst way by just writing it out here in the source. Don't do this unless you're just doing a quick example. Okay, it's gonna say it didn't find a bunch of stuff. That's fine here. Good. I thought these days GCC was including those for us. Oh boy, what have I done here? Getting rusty on my C programming. Okay, undefined reference. Okay, no problem there. Let's see if I include, well, the file is right here. So let's just do, oh, it's probably HPP. Oh, interesting. Ran HPP and .h. Okay. Now I need to link it in the library. You know what? Let's stay in our include path here. Okay, so I need to statically link Wren in. Okay, so I have the CLI here. How do I build this? Let's see here. This is worth spending a little bit of time because you might also want to do this type of thing here. So let's see here. I think I need to build this as maybe a static library or something. Embedding. Getting started. Okay, if I want to embed this, okay, run make inside projects make. CD into projects. And I just run make. Okay, I need a CD into, what is it? Run make inside projects / make, one more directory. Oh, I see, it's got pre-make and all the other things here. Okay, let's see if it goes. And I didn't do a parallel build or anything, so it is super fast here. Okay, so I must have the object files. It figured out this is a 64-bit system. It did the release build for me. If I look into Wren here, these are the libraries here. Let's go back to the shared libraries. All right, and this is probably where I want to link into. Maybe. Let's see here. There'll be library files. Oh, in the root lib folder. Awesome. Okay, because I was looking for like a shared library. I didn't want to link that stuff. Okay, so let's go into the library. And I have this file. Perfect. Okay, so now when I do my little test here, and it gets undefined reference, again, those aren't compiler errors. Those are usually means I'm missing this library here. So let's just add that to our library path here. This is going to be a little bit ugly here, but that's okay. I just want to see if it works, and then, you know, if any of you want to try this, you can also try this. Okay, I linked it. Let's put in the specific library, Wren, and it worked. Okay, let's put that whole string for you. There it is. So again, I have the test program that they provided. I'm just going to call this prog, found the library, and put in the library that we compiled. And I run it. What did I get here? Can I open a shared object file? Let's see here. So linked, why didn't it open? Do I not have permission? Let's see here. A preemptive celebration here. Oh, I wonder if it tried to link maybe the archive file, and it doesn't have error. Okay. What have I done here? Lib. Let's see here. That's saying can't find it, but now it can find it, and then now it's just having errors linking in here. Let's see. All right. Maybe I can explicitly put the SO file there. Note the default build will generate inside a bin. Okay, let's see here. Let's see here. Otherwise, we can. You don't have to specify the whole library, which I always thought was a little bit weird in compilers that you don't specify this. But anyways, there we go. So it figured it out, but I wonder if it's taking in that archive file. Does it need execute permissions for that? No, it should be able to read and write. And then when I run this, error while loading shared library, librena. So cannot open. Okay, so it's loading the right one here, but it says there's no such file or directory. So it is possible that I've just messed up this path here that I am in. I didn't copy it in. Home, mic, downloads, Wren CLI, /Wren/lib. I'll try one more thing here, otherwise we'll just call it what it is here, but this is an issue of like the backslash, not finding it. Yeah, interesting. Let's just check if it's being picky on the path order. This used to be a problem more so on different compilers for whatever reason here, or if you didn't put the path beforehand, it would complain or not get in the like executable. I don't know what's going on here. Why I can't find it here? I wonder. Here, we can cheat here and just put in the whole file. Why can't it find that whole path here? Interesting. let's just do a little bit tiny more debug here. So that's got the right library, found the right path here. Let's see here for prog here. It says not found for some reason. So LDD is a tool for looking at what dynamic libraries are available. Here it is. But for whatever reason, it's not finding it in this path here. So I can specify a relative path. I could cheat a little bit, and let's just, well, we could do a little bit of cheating here. Let's see if I copy from this path here. Downloads, Wren, here. Let's just see if I just drop it in this directory here, if it finds it. Because it's going to look in the default directory. For whatever reason, it didn't find that path here. Okay, and then we'll put the search path to just be dot. Oh, interesting. Actually, I wonder, is GCC being really picky with me with spaces here? Let's see here. Error, interesting. Very interesting. Well, let's just clean this up here. Let's see here. Okay, I'm just going to cheat here a little bit and just put, for whatever reason, my path here doesn't want to play nice here. So I'm just going to put the path to look for LD on the path here, and then I could just rebuild this as I was doing here. Let's see here. Something like this here. Anyways, I could play around with the build system, but it is working here. Okay, so my fault, not the programming language's fault here. But anyways, if you want to get this example working here, let's navigate these just a little bit here. Pretty simple here. I mean, we're able to get the script run, so that's pretty cool. That's encouraging. I mean, I could wrestle around with the build system and the libraries a little bit, but for what do we wrestle with that, like 7 or 8 minutes? Not too bad. Not too bad at all here. So anyways, the last thing I believe I promised was going to be to show you the thing that kind of started this all. I saw this on Hacker News here just a few hours ago, which led to this language for the 10th time here. And apparently this game engine is using the Wren for scripting. So that's pretty cool here. So it made a custom version of the Wren programming language. So I guess somebody's forked this or maybe added on to what is there. And this engine itself, I mean, maybe we need a series on doing game engines and stuff. That would be kind of fun. So folks, let me know if you made it to the end of this video. Let me know that, but let me know if that'd be something that you're interested in. But this is pretty cool here. Cross-platform game engine actually using this scripting engine. So it's always nice to see where these tools get used. Wren itself, I wonder perhaps more in the maybe in the Q&A or other sections of the blog or whatever, folks talk more about where this is being used here. But yeah, this is kind of cool. This has been a fun experiment. This is probably one of our longer ones. And the reason it's a little bit longer, I mean, one, of course, is having fun, but I mean, we pretty much covered most of the language. There are some things to dive into, but this is a language that you could probably, if you wanted your team to have scripting capabilities, get set up relatively fast. So this is cool. I'd like to see or maybe look at more scripting languages. And it looks like the Q&A goes a lot more into the design here, as well as some of the other languages that have been built, also named after birds, finch and magpie, I guess. It's a cool trend. But, overall, this is really fun language to take a look at. So anyways, folks, with that said, let me know what you think about the Wren language, if you've used it, if you try it out, if you do some cool experiment, if there are things that I missed, especially if you're one of the contributing authors and there are things I should know about, or if you're using this in any of your projects or considering using this or something like it. Again, I had a lot of fun here, and again, just a really, nice, concise set of features, but very complete, very powerful, and a really nice concise syntax. That's what I'm taking away from this. A bunch of things that I don't think we had seen yet in this series, which again always surprises me as we're 40 plus videos in on this series. So anyways, folks, thanks for your time and attention. As always, I hope you enjoyed this video. Again, we're breaking records in the length perhaps here, but it's really a lot of fun here, and I'll look forward to seeing you in the next episode. Take care.